Hello everyone, my name is Guru Kiran and today topic is Knapsack 01 algorithms, where Knapsack 01 algorithms is a problem solved by using a dynamic programming approach. Where dynamic programming approach is a types of the problem solving methods which can be divide the problems into smaller subproblems for easy to solve, and also dynamic programming approach solve the different types of the problems, and some are such as 01 knapsack algorithms and string and sequence problems and matrix based problems. As I said before, the knapsack 01 problems is also solved by the dynamic programming approach. Let us know about why we call it as 01 knapsack algorithm. Means if you consider a bag having a capacity of 15 kgs and 4 items having 5 items 12 kgs, 2 kgs, 1 kgs, 4 kgs and 1 kg. If you put items into 12 kgs into a bag, its weight is 15, it is 12. Okay. Then if you put up 2 kgs into a bag, okay, it is also 14 kgs and 1 kg. If you put a 4 kgs into a bag, it exceeds the bag limits. So you cannot break the item or put in. You can place a whole item or leave it the entire item. That's why we called as 0, 1 knapsack. Now, 0 or 1 knapsack algorithm. Here, the weight of the bag vary from 0 to W, but there is no item, then initialize first row is equal to 0. Similarly, the items vary from 1 to n, but there is no space in the bag. In that time also you can initialize 0. At the last condition, if item is also there and the weight of the bag is also there, first you check the weight of the item is less than or equal to weight of the bag. If it is true, you can insert the element and add the profit of that items. If it is false, you can take a previous value. Now we are discussing about one problems. Let us consider n is equal to 3 and w is equal to w1, w2, w3. These are the weight of the items which has 2, 3 and 3. And p is the items p1, p2, p3 are the profit of the item, and m is the maximum capacity of a bag. As I mentioned in the algorithm, if the weight vary from 0 to W, but there is no item, you can initialize 0. Similarly, if the item vary from 1 to n, but there is no space in the bag, you can initialize 0. Let us come to the table. See, if there is no weight in the bag, but there is have items, then you can initialize 0. Similarly, if have here also and here also. Then the items, there is no item, but the bag having a capacity of 1. This time also you can initialize 0. And if the weight of the bag is 2, there is no item, that time also you can initialize 0. The weight of the bag is 3, there is no item, that time also initialize 0. The weight of the bag is 4, 0. Weight of the bag is 5, 0. And weight of the 6 is 0. Let us insert the first items into a bag. When you insert the item into a bag, the weight of the bag is greater than or equal to the weight of the item. Let us, the formula of is V of k comma w is equal to max of V of k minus 1 comma w, V of k minus 1, w minus w plus p, where capital W is the weight of the bag and small w is the weight of the item and p is the profit of the item. Why we can use a max? Because we can put the items into a bag according to their maximum profit. That's why we can use a max. Here V of 1 comma 1. The bag weight is 1, but there is item weight is 2. So the bag item is lesser than or equal to item weight. That's why we can is equal to 0. Then v of 1 comma 2. According to formula, max of v of k minus 1 is equal to 0 and the weight of the item is 2 comma v of k minus 1 is 0 and the weight of the bag and weight of the item is same, so 2 minus 2 0 plus profit of the first item is 1. That's why 1 is equal to max of v of 0 comma 2. v of 0 comma 2 is equal to 0 and v of 0 comma 0 is equal to 0 plus profit of the first item is 1 is equal to 1. Similarly, v of 1 comma 3 is equal to 1 and v of 1 comma 4 is also 1. v of 1 comma 3 is also 1 and v of 1 comma 4 6 also 1. Now insert the second item. The second item having a weight 3 and having a profit 2. When insert v of 2 comma 1, similarly the weight of the bag is lesser than weight of the item is equal, that's why is equal to 0 and v of 2 comma 2, the weight of the bag is also lesser than weight of the item, so you can take the previous value is equal to 1. Similarly, v of 2 comma 3 is equal to max of k means 2, 2 minus 1 is 1 and weight of the bag is 3 comma v of k minus 1 is equal to 1 and weight of the bag and weight of the items are same is equal to 0 plus the profit of the item 2 is 2 is equal to max of v of 1 comma 3 is 1, v of 1 comma 3 is 1 and v of 1 comma 0 is 0 plus profit 2 is equal to 2. Similarly, v of 2 comma 4 is equal to max of v of 1 comma 4 comma 1 comma 1 plus 2 is equal to max of v of 1 comma 4 is also 1 and 1 comma 1 0 plus 2 is equal to 2. Now v of 2 comma 5 is equal to max of v of 1 comma 5. v of 1 comma 5 is 1 and v of 1 comma 2. v of 1 comma 2 also have 1. 1 plus 2 is equal to profit is 2. So 1 plus 2 is equal to 3. So max of 1 comma 3. So maximum is 3. That's why we can consider 3. Similarly, v of 2 comma 6 is also 3. Let insert item 3. The item 3 having a weight 3 and profit 4. When v of 3 comma 1, the weight of the bag is 1 and weight of the item is 3, so weight of the bag is lesser than 3, so you can consider a previous value is 0. Similarly, v of 3 comma 2, the weight of the bag is 2 and the weight of the item is 3, so weight of the bag is lesser than weight of the item, so you can consider a previous value 1. Now v of 3 comma 3, according to a formula, k is equal to 3. Max of v of 3 minus 1 2 and weight of the item is 3 comma v of 2 comma weight of the bag is 3 minus weight of the item is 3 0 plus profit of the item 3 is 4 is equal to max of v of 2 comma 3 is 2, v of 2 comma 3 is 2 and v of 2 comma 0 is 0 plus profit 4. Max of 2 comma 4, maximum is 4, so let us consider a 4. Similarly, v of 3 comma 4 is also 4. Now v of 3 comma 5, v of 3 comma 5 is equal to max of v of k 3 minus 1 2 comma weight is 5 comma v of k minus 1 2, weight of the bag is 5 and weight of the item is 3, 5 minus 3 is 2 plus profit of the item is 4 is equal to max of v of 2 comma 5 is 3 plus V of 2 comma 2. V of 2 comma 2 is 1 plus profit 4. Max of 3 comma 5. Maximum is 5. So consider 5. V of 3 comma 6 is equal to max of 3 minus 1 2 and weight is 6, and V of 2 comma 3 plus 4. V of 2 comma 6 is 3 and V of 2 comma 3 is 2 plus profit 4. The maximum is 6, so consider 6. Now we check what are the items present in the bag. How to check what are the items present in the bag means check if the last row last value or changes from that row or previous row. Means if the last row last value this one, it is checked, it is changes from this row or previous row. If it is changes from this row, consider that item and move previous row and move left has the weight of the item. Similarly, if there is no changes from this row, move previous and check the last value of that row. If it is changes from this row, you can consider this item, or else you can move until it just the 0. Now we can find the what are the items present in this table. Means the 6. 6 is changes from this row, so we can consider the item 3, move previous row, and the weight of the item 3 is 3. Move left 3 step back, 1, 2 and 3. Now it shows the value 2. The value 2 is changes from this row. That's why we can consider item 2 also and move previous row. The item 2 also having a weight 3. Now 3 step back, 1, 2, 3. It reaches 0. So the bag which contains item 2 and item 3. Now we find the keep matrix. Keep matrix are the matrix representations using 0 and 1s. The sum of the rules are there for writing a keep matrix. First one, write 1 only when V of n comma w changes. Means consider this example. Here first one is 0 and second one is 3. Here the changes, so you can write 1, 4 changes 1 and 5 also change 1. Now second rule is V of n comma w from one row and V of n comma w from another row is equal, then it is right 0. Means consider first row, this is first row, right? This is second row. First row of second element and second row of second element same. So in the second row of keep matrix write 0. As I said in the previous slide, the keep matrix are right for this. This is all are 0 and this and the first row and first column is 0. So write 0 and first row of second column is 1. Here is the change. So you can write 1. After all same. So 1, 1, 1. Now the second row of second column is 1. It is equal to the first row of second column. That's why we can write 0. And the second row of third column is changes, so we can write 1, then 1, 1, 1. Now similarly the third row of second column is equal to the second row of second column, then we write 0 according to the rule of 2. And the third row of third element is 4 is changes, then we can write 1, 1, 1, 1. And finally I thanking to all for your attention.